Today our topic is Regula Falsi method. The Regula Falsi method is a numerical method for estimating the roots of a polynomial. See the geometrical interpretation. Let the curve y equal to fx cut the x-axis at the point x equals to a. So, a is a root of the equation fx equals to 0. Now, we first choose a sufficiently small interval x0, x1 in which the root lies. So, there is a point A, the point is A, x0, fx0 and another point is B, it is x1, fx1. And we first choose a sufficiently small interval x0, x1 in which the root A lies. Since the interval x0, x1 is sufficiently small, the portion of the curve between A x0 fx0 and B x1 fx1 can be approximated by a straight line. So, the intersection of the line AB with the x-axis gives an approximate root x2. Repeat the same step till we get fx equals to 0 or fx less than equals to accuracy. So, the equation of the line AB is x2 equals to x0 fx1 minus x1 fx0 divided by fx1 minus fx0. Working rule. Given fx equals to 0, find x0 and x1 such that fx0 less than 0, that is negative, and fx1 greater than 0, that is positive. That is fx0 into fx1 less than 0. So, the root of the equation 1, this equation lies between x0 and x1. Find first approximate root by Regula Falsi method, which is x2 equals to x0 fx1 minus x1 fx0 divided by fx1 minus fx0. Find fx2 and examine its sign. If fx2 less than 0, then replace x0 equals to x2, and if fx2 greater than 0, then replace x1 equal to x2. Find second approximate root by Regula Falsi method, that is x2 equals to x0 fx1 minus x1 fx0 divided by fx1 minus fx0. Find fx2 and repeat step 3 until the required accurate root. So, the nth approximate root is xn plus 1 equals to xn minus 1 fxn minus xn fxn minus 1 divided by fxn minus fxn minus 1. We will discuss one example, then it will be more clear for you. Take one mathematical example. Find the real root of the equation x cube minus 4x minus 9 equals to 0 by Regula Falsi method, correct up to 4 decimal places. So, what is our equation? Say it is fx. Fx equals to x cube minus 4x minus 9 equals to 0. So, to find x0 and x1, we start from value of x as 0. So, what is the value of f0? It is minus 9, that is negative. Now, f1, it is minus 12, it is also negative. f2, it is minus 9, it is also negative. f3, it is 6, it is positive. So, I can say that root lies between 2 to 3. Now, I have to choose one point in between 2 and 3, say it is 2.6. So, what is f2.6? It is negative. So, I can say that root lies between 2.6 to 3. Now, I have to choose one point between 2.6 to 3. I am choosing 2.7. It is also negative. So, I can say that root lies between 2.7 to 3. So, I have to choose one point between 2.7 to 3. I am choosing 2.8 and the result is positive. If 2.8, the result is positive. So, I can say that root lies between 2.7 to 2.8. Choosing x0 as 2.7 and x1 as 2.8, I am start drawing this table. In this table, there are 6 columns. First one is xn minus 1, then xn, then fxn minus 1, fxn, xn plus 1 and fxn plus 1. And this is our formula. So, what is the iterative solution of Regula Falsi method? Regula Falsi method can easily be solved using calculator memory. See how? So, what is xn minus 1? We already calculated, it is 2.7. I store it in the variable of calculator memory. It is a. And then what is xn? It is 2.8. I store it in the variable b. So what is f xn minus 1? What is xn minus 1? It is 2.7. So f 2.7. So I get this value. I store this value in the variable of calculator. It is c. And what is f xn? What is xn? It is 2.8. So f 2.8. The value is this. I store this value in the variable of calculator. It is d. So what is xn plus 1? According to this equation, xn plus 1 is xn minus 1 into fxn, that is a into d minus xn into fxn minus 1. Xn means what? B into c divided by fxn minus 1 divided by d minus c. In this way, you have to write this equation and I get the result. So what is the value of f xn plus 1? It is negative. If the value is negative, then the root lies between 2.706260 to 2.8. So I have to change it accordingly. And if the value is positive, then I have to change which value? This value. And if the value is negative, I have to change which value? This value. So what is the new value of xn minus 1? It is 2.706260. I stored this value to the variable a. What is f xn minus 1? This value. I stored this value to the variable c. Value for b and d are still same. Now, according to this equation, calculate the result of xn plus 1. Now calculate f xn plus 1. It is negative. If it is negative, then I have to change the value of xn minus 1. If it is positive, I have to change the value of xn. Now it is negative, so I have to change the value of xn minus 1. New value of fxn minus 1 I have to calculate. So first, what is xn minus 1? It is 2.706516. So I have to store this value to the variable a. Then calculate f xn minus 1. I have to store this value to the variable c. b and d values are still same. According to this equation, calculate the value of xn plus 1. Now see here, the value of fxn plus 1, it is 0.000 almost equals to 0. And values of xn plus 1, see it is 2.7065, 2.7065, same, that is they are same up to 4 decimal places. So we can say that the approximate root is 2.7065 and it is correct up to 4 decimal places. Now it's time to practice. So this is your problem set. Try to practice this problem and feel free to ask any question. First, take a screenshot. The answer is given by the blue ink at the end of each problem. So first, pause this video, try to take one screenshot and solve the problem. If you are facing any problem, you can comment in the comment section so that I can give you the solution of this problem. Now I am showing the total problem set. For getting more and more updates, please like, share and subscribe my channel. That's all for today. Thank you.